All right, now to explain these proposals, I'm going to focus on three of them. I'm going to use an analogous setup, one that's more in the macroscopic realm. I'm going to imagine a situation where I'm throwing a dart at a dartboard, and the classical description involves us following the motion of the dart. It has a definite location and a definite speed all the way through its journey from my hand to the dartboard. That's what Isaac Newton would have said in describing this motion, and it's what everybody would have said after Isaac Newton, before the 1930s, when quantum mechanics came along. What we want to do is try to understand the quantum version of this very simple story. So the quantum version, we know, involves replacing the dart by some kind of probability wave, and just as the dart is going to hit the screen, somehow that spread out probability wave has got to yield something that allows us to say the dart is at one location or another, not some spread out probability where it might be here, there, or over there. So that's the puzzle. How do we go from this spread out probability wave to the dart hitting the board in one location? Now, one set of solutions, which I won't focus on much, but is worthy, definitely worthy of attention, has to do with a group of physicists over, in fact, many generations who have come up with various versions of this idea. They say the issue is not so much trying to understand what's happening out there in the world. They say quantum theory is actually describing what happens up here. Quantum theory is not a description of an existing external reality, they say, or suggest or try to convince us. Quantum theory actually tells us, about our understanding of the world. So they would simply say, when the dart hits at one location or another, and I look and I see it, let's say it hits right in the bullseye, then my consciousness, my brain, my understanding of the world has changed, and that's the only change that ever happens. There isn't some objective wave that's out there in the world that needs to spike. Quantum theory is simply talking about my understanding of the world. Now, many of us recoil. Maybe those ideas are right, but many of us recoil at those ideas because we're committed to a view that there's a reality out there, a reality that we, physicists, are charged with understanding, and to somehow place human beings or consciousness or mind or understanding at the center of our description of the world, that seems like a step backwards, a step into old times when somehow we thought of ourselves as central to reality. Since Copernicus, we've been on a constant series of demotions, right? We thought that the Earth was the center. Then, well, maybe the sun is the center. No. Maybe the galaxies. No. We're just one of many, many planets around many stars, around many galaxies. There's nothing central, we think, about us or life or consciousness. So if we put that to the side, it's hard to accept that that's the answer. So the three approaches that I'm now going to say a few words about really envision, as we have for decades in science, that there's an external world, and it's our charge to explain how it behaves.
I'm curious about the path that you didn't go down around there being, assuming that there's an external reality. Is there a way of creating math around the idea that maybe it's internal, and what does that say?
Yes, in fact, in many ways, the proponents of a proposal that ultimately quantum mechanics is really a description of us, our understanding of whatever's out there, without committing even to what's out there. That math is the math of quantum mechanics, together with interpreting it in a different way. I mean, it's a kind of strange thing, and many people who think about science don't think about science as something where there's an interpretive step. You got the equations, you work them out, you make a prediction, you test it, and it works. That's sort of what we teach kids in the classroom, right? But in reality, there's another step that the philosophers have highlighted for a long time, which is you've got to draw a really powerful dictionary between what these symbols on a page are and how they relate to what's out there. And you have to commit to an ontology, what's real, what's out there. I hadn't even learned the word ontology until I was like 40, right? So they don't teach you that when you're a scientist. So in this other approach, this is what's real, and the math is describing our experience. And certainly our experience is the case that if an electron is out there and you don't know where it is, and then you measure it, after you measure it, you do know where it is. So you have changed in a kind of discontinuous way, nearly discontinuous way. You didn't know where it was, you did. And therefore the wave going from spread out to sort of a spike, it's not really a physical process in the external world, it's just what's happening inside your head. And then it becomes somewhat easier. Now this is somewhat of a cartoon of that explanation. The most refined version is something called cubism. So you can read about it, but that's the basic idea. That our mistake was thinking that these waves are out there describing an external world, and actually it was just describing us.